In conjunction with the University of North Texas Engineering Technology Department and funding through the American Society of Engineering Education, we present to you the Optical Spectroscopy Research Project, brought to you by Senior Design Group 2 and Dr. Mauricio Monzo. Rhodamine 6G is a highly fluorescent powder from the rhodamine dye family. It is often used as a tracer dye within liquid to determine the rate and direction of a flow of a liquid. Rhodamine 6G's fluorescence can thus be detected easily and inexpensively with instruments such as flow meters and spectrometers. The properties of rhodamine 6G make it the optimal specimen in measuring change in spectrum intensity versus temperature. The thermocouple is used to measure the temperature of the specimen at any given time to later be used in calibrating the data of the intensity of the light spectrum versus the specimen temperature. The thermocouple is used to calibrate the sensor based on the rhodium 6G dye. A thermocouple gives a more accurate reading of the temperature than the hot plate readout, leading to more exact data. The hot plate acts as a heat source, raising the temperature of the specimen at a constant value. This gives us a vital baseline understanding of how the spectrum of rhodamine 6G behaves when subjected to changes in temperature. A spectrometer is an apparatus used for recording and measuring spectra, especially as a method of analysis. In our experiment, the spectrometer is used to measure the change in the amplitude of a specific wavelength in a spectrum given off by the fluorescence of rhodamine 6G. The spectrometer is used in conjunction with OceanView software, which compiles the data gathered by the spectrometer and outputs useful values of wavelength intensity, which can be compared with change in temperature. Utilizing a focused light source in terms of known spectrum wavelength gives us a fixed baseline, which is used to calculate the variable intensity at that specific wavelength. Two different light sources are used to ensure a consistent trend in data. The two light sources used in this experiment were a 532 nanometer laser and a lamp used to emit an ultraviolet wavelength. The software used in this experiment is the OceanView Spectroscopy software provided to us through the University of North Texas laboratories. This software processes the wavelength and intensity of the light spectra emitted by both the light source and the specimen. Here, that process of data collecting is shown. In order to compile meaningful data, Microsoft Excel is a common tool used to give a visual representation of the data collected. Data collection and processing is used to portray meaningful results in a visual format to show trends in the collected data. After all the data is compiled into a graph for each light source, the data is able to visually show the following trend. As temperature increases, the intensity of the spectrum given off by the specimen decreases. The goal of this lab is to create meaningful and intriguing laboratory experiments that involve common engineering concepts and demonstrate potential uses for optical spectroscopy. Within the Engineering Technology Department here at the University of North Texas, hands-on experiments give the students a real-world application and understanding to the concepts being taught in the classroom.